Hey everyone, Dr. Tom McNamara back again for our course in trigonometry. In this video we are going to continue our work proving identities. In this video we're specifically going to look at proving identities using the Pythagorean identity. In other words, we're going to be dealing with stuff that involves squares of trig functions, and we're also going to work with a few examples that involve fractions. So let's get right to it. So here's what I want to do for you. Let's try this. Okay, so we're going to prove that cosine power 4 of t minus sine power 4 of t over cosine squared t is equal to 1 minus tan squared t. Okay, so one thing I still want to remind you about is this difference of two squares factoring. And another thing I'd like to remind you about is that a fourth power is a square. You remember your rules for exponents? If you raise a power to another power, you multiply those exponents. Okay, so my numerator here is difference of two squares. It's cosine squared squared minus sine squared squared. So let's follow our general advice from the last video, starting with the more complicated side. Okay, so what can I do? Well, I'm going to factor my numerator. Right, now, nothing's really canceling because there's no factor of cosine squared. You might say, well, there's a cosine squared right there, but that's not a factor. It's added to this other thing. Factors are multiplied together. However, there is a way to simplify this quite a bit. This right here, cosine squared plus sine squared, that equals 1 by the Pythagorean identity. Okay, so cosine squared t minus sine squared t over cosine squared t. And now I've got these two things over this numerator right here. Okay, I can break it up. This is cosine squared t over cosine squared t minus sine squared t over sine squared t. Oops, sorry, that should be cosine. Cosine in the bottom on both of them. Okay, so in a way I'm kind of like distributing. Okay, now this is a 1. Sine over cosine is tangent. They're both squared, so I got tan squared. 1 minus tan squared t, and that was the right-hand side. Okay, so start with the more complicated side. If it's not already done, write everything in terms of sine and cosine. Here we didn't need to do that step. And now we're doing some factoring. Whenever you see that difference of squares, pull in that difference of squares factoring. I bet good things will happen if you do. Okay, let me try one or two more examples. I said I wanted to do an example that involved fractions. So let's try one. Okay, I'm going to pull one from the from the book here. Okay, how about this one? We are supposed to prove that, oh, where was it? I just had it. Okay, 1 over 1 minus sine x plus 1 over 1 plus sine x is equal to 2 secant squared x. Okay, so I'm starting with this side. All right, now, I'm starting with the left side because that's the more complicated side. I got fractions over here, no fractions over here. To me, that looks more complicated. Now I got add fractions. What do I need to do when I'm adding fractions? I got to get a common denominator. Oof. I'm going to have to squish this in here. But I think it's going to work. Okay, so got my fractions here. I got to add fractions. Need a common denominator. How do I get a common denominator? Well, you take the denominators that you do have and multiply them together. So my common denominator is 1 minus sine x times 1 plus sine x. This already had a 1 minus sine x downstairs, so we're going to hit this first fraction with 1 plus sine x, top and bottom. This second fraction, it already had the 1 plus sine x, so we're going to hit that second fraction with 1 minus sine x, top and bottom. Now that you've got your common denominator, you can combine the numerators and put that over the common denominator. All right. Now, in my denominator, I'm going to multiply them out. Okay, first times first, 1. Outside times outside, sine x. Inside times inside, negative sine x. Those cancel each other out. I got a plus sine x, I got a minus sine x. They cancel. Last times last. Negative times positive is negative. Negative sine squared x. All right, up top, I'm seeing I got a plus sine x, a minus sine x. Those go away. I'm left with 1 plus 1. 2 in the numerator. Down here, use your Pythagorean identity. 1 minus sine squared, you can replace that. Cosine squared. All right. Got a cosine in the denominator. Cosine downstairs, that's the same thing as secant. If cosine was squared, it's secant squared. 2 secant squared x. I can stop. How do I know that? Well, that was the right-hand side. Okay, so once again, starting with the more complicated side. Doing some algebra. In this case, it's algebra with fractions. You're doing algebra with fractions, you got to get your common denominator. I want to show you one more technique of dealing with identities that involve fractions. Okay, let me see. Okay, I want to do this one. Prove that cosine t over 1 plus sine t. Okay, cosine t over 1 plus sine t. We want to prove that is equal to 1 minus sine t over cosine t. Alrighty. Now let's see what we can do here. Okay, so now I'm not going to be adding fractions in this. I'm going to try to turn one of these fractions into the other fraction. Okay, so I'm going to start with this side. I'm going to start with the left-hand side. Alright, well, what's this equal to? Alright, so here's what I'm going to try. And like I said, it's a technique of dealing with these things that involve fractions. Now, I want these two things to be equal. Now, I can keep the fractions the same if I multiply the top and bottom by something. Okay, now notice this has a 1 minus sign t on the top. So I'm going to throw that in here. Now, I can't just multiply the top by 1 minus sine t. I've got to multiply the bottom by 1 minus sine t as well. Okay, so up top, I've got cosine t times 1 minus sine t. So I've got part of what I want. Notice downstairs I've got cosine. Now let's think about what happens when we multiply these denominators. Okay, I got 1 plus sine t times 1 minus sine t. First times first is a 1. Outside times outside, minus sine t. Inside times inside, plus sine t. Those cancel out. Last times last is minus sine squared t. So we're getting closer. I'm looking at my target here. I got the 1 minus sine t on top because I hit the top and bottom with that factor. Now, in my denominator, I multiplied out 1 minus sine squared. I use my Pythagorean identity. One minus sine squared t, that is equivalent to cosine squared t. All right, now we're even closer. Up top, I got a factor of cosine t. Downstairs, I got two factors of cosine t, right? Cosine squared t. This cosine cancels out with one of the two factors I've got down there, and I'm left with 1 minus sine t over cosine t. All right, so in the last example, we were working with fractions, we were adding them, had to get a common denominator to add the fractions. In this example, well, we just got one fraction, but we hit the top and bottom with the same thing. Okay, now you gotta make a nice choice here. You can't just multiply willy-nilly by anything, okay? The thing that we were relying on is getting the Pythagorean identity to apply to that denominator. Okay, there's a reason. I started with 1 plus t, there's a reason I chose 1 minus sine t. One of the reasons is that factor was up here, so I threw it in there. Okay, the other reason is 1 plus sine t times 1 minus sine t is 1 minus sine squared, which is equal to cosine squared, which cancels that out. Okay, so multiplying the top and bottom by the same thing. Another important trick, another important technique when you're dealing with trig identities that involve fractions.